Hi, my name is Gabriel, and today I'll be talking about what is porosity and what is density. Porosity is a percentage of void space in a rock. It is calculated by dividing the volume of void or pore space by the overall volume. It is written either as a decimal fraction between 0 and 1 or as a percentage. Porosities depend on many factors, such as particle shape, degree of packing, and degree of sorting. For example, sandstones typically have a much higher porosity because of the individual sand or mineral grains are not closely packed together and thus allowing for much larger pore space. And now, density. Density is defined as the mass per volume. For example, in rocks, it is a function of the densities of the individual grains, the porosity, and the fluid filling the pores. There are three types of densities in rocks. One, dry density, two, wet density, and lastly, grain density. Dry density is measured on rocks without any water or fluid in their pores. Wet density is measured on fully saturated pores, while grain density describes the density of solid or mineral grains of the rock. That is all from me. Thank you.
Hello everyone, my name is Inichi and I'm going to explain the procedure of this experiment. There are 6 specimens used in this experiment, which are aluminium, steel, glass, glazed tiles, refractory, and brick. So the first step is weigh each of the dry specimen and record them in 2 decimal places. Then tie the specimen with a thread and put it in the boiling water for about 10 minutes to allow the water to penetrate into the pores of specimen. After 10 minutes, weigh the specimen when it is suspended in water. Then take out the specimen from the water and use the edge of filter paper to remove the residual water. After that, record the weight of the specimen when it is suspended in air. Repeat all the steps for the rest specimens. That's all from me, thank you.
Hello guys, my name is Junwei. So after we have talked about the procedure of this experiment, so let's have a look on our result gained from this experiment. So now we are proceeding to the calculation part. So let's have a look on the screen. Okay. Before I proceed to the calculation part, I would like to introduce to you all 2 formulas. The first formula is the bulk density, which is rho B. The rho B is equals to WD divided by the product of WW and WS, where WD is the weight of dry specimen, WW is the weight of specimen suspended in air, and WS is the weight of specimen suspended in water. So the unit for bulk density is gram per cm cubic. So that's the first formula. The second formula is going to be apparent porosity, PA. The PA is equals to the product of WW and WD divided by the product of WW and WS and times with 100%. Of course, the unit for this is percent. So now let's proceed to the calculation step in calculating the porosity and also the bulk density for aluminium specimen. So let's start with bulk density. To calculate the bulk density is pretty simple. You just need to substitute the value of WD, WW and also the WS into this formula. So the WD for my aluminium is going to be 3.21 gram, and that's divided by the WW, also 3.21 gram, and times with the 3.22 gram. So the final answer for bulk density of aluminium should be 0.31 gram per cm cubic. As well as the porosity, you just need to substitute the value again into this formula. And times with 100%. So the final answer for this porosity is going to be 99.69%. Now it's pretty simple. So we just apply this method to calculate for other specimen. Now I'm showing the answer we get from the calculation for the other specimen. So that's all for this video. So thanks for watching and goodbye.